really, in some respects, especially if you are choosing a therapeutic pathway, which means that you're trying to take on a disease, what they have to do is they have to choose a target disease that is acceptable to the infrastructure of the healthcare system as it is today. So you might have a therapeutic that works on multiple aging pathways. It may be, in the case of like the GLP-1s, that's a prime example. You know, it protects protects the heart from stroke and heart attack. It's proving in my studies to be neuroprotective, but of course it's got the weight loss as well, which obviously removes the metabolic stress on the body. So that is actually addressing three parts of the longevity disease matrix. And we asked the founder, the discoverer, is it a longevity drug? You know, he thought about it and said yes. I've talked to other people in the industry, you know, is it a longevity drug? And they said yes. I'm not sure I can back it up, but I think we were pretty much the first to actually call it as a longevity drug. And you see where that goes in the future, right? But actually that drug has been designed around one target disease so it can get approved and get into market. And then once it's in the market, it can then go, as we say, off-label and be applied to other therapeutic areas. So the biotechs that are in the space now, those that are taking the traditional routes of choosing a disease to target, they're taking a traditional route, but it's still challenging, and they still have to prove that they can affect cardiovascular disease before they can then start to open up their platform to other disease areas. So then, of course, you've got therapeutics that are in the space like gene therapies or cellular reprogramming.
That one scares me when I hear about, you know, they talk about CRISPR and the gene therapy. It's that seems to be something seems to be able to go wrong in that world.
Well,
it's easier, and coming from a position mostly of naivety, to be honest, but it's the one that scares me the most.
Well, I guess at the end of the day, the rigor of healthcare approvals is what this is all about. You know, so when you're looking at the chasm, to coming back to that, so you've got the pre-chasm and post-chasm, right? So post-chasm is what they call the early majority and the wide majority. So that's all of us, just regular citizens around the world that kind of, you know, like to do as they're told. And that's when it's gone through the drug approvals process and the rigors of those processes that are well established, that people obviously kind of rail against because it takes too long, it's too detailed. You know, why can't we just get on and get access to these therapeutics? Well, the reality is that actually they may have significant side effects. And unless you're doing the rigorous process that you need to do for clinical trials that are set up around the world, you're not going to be in a position where people like yourselves are going, well, you know, I'm scared of gene therapies. Well, yeah, you should be, because, you know, you don't know about them. But if you're being prescribed one that's been through the right rigorous process that it needs to be, then I'd be saying, go for your life. You know, it's going to help you. So why not do it? So the issue that, you know, we're talking about at the moment is some of these more extreme therapies, for example, like cellular reprogramming, which is the concept of taking a cell and rewinding the age of that cell to the point where it still recognizes what it's meant to do as a cell, but it's in a younger state. And for a very long time, we've been able to have what are called pluripotent stem cells, which are cells that you can rewind back to a completely embryonic state. So you can take a cell out of a donor or out of yourself, you can take it back to zero, and then you can kind of reprogram it to be whatever it needs to be, whether it's knee cartilage or heart tissue or whatever it may be. So, you know, quite a complex process, and of course, very personalized and very expensive. Whereas actually, if there's a therapeutic that can reprogram every cell in your body to a younger state, and it's not targeted at a specific part of your body, like trying to regenerate your heart, but it's actually regenerating the whole body, then of course, conceptually, that's really where the science fiction of what's happening in the longevity field really starts to come into play. Because really, at the end of the day, if you're in a position where you can access these therapeutics when you hit your 30s, and theoretically you stay in your 30s for as long as you can afford or have access to those therapeutics, then, what the hell, who's not going to take that? And that's where the concept of all of these discussions about longevity, escape velocity, and immortality, and all of those things come into play. And that's, I speak to a lot of people, as you know. I speak to a lot of people in different industries, and the space industry is one that's, I love science fiction, and it blows my mind. I was talking with a guy at an event, and he's very seriously talking about all the things that we've heard about, mining meteors, stations on the moon, colonies on Mars, all of those things. And he's talking about them as a genuine investment opportunity and stuff that's going to happen. And when you look at what's going on in Silicon Valley, where a lot of the big tech money from obviously the work that they've done in social media, whatever it may be, these tech entrepreneurs are now swinging around and focusing on what they can do for their own longevity, but also the longevity of humankind. Concepts of cellular reprogramming are attracting a lot of capital. Of course, there is a lot of new tech coming in. So a lot of these early therapeutics are being discovered by AI. So AI is accelerating the early recovery process. So what they're doing is actually they're creating a downstream challenge for the industry, because they're coming up with so many theoretical targets that they would consider to be valid, these systems being they still then have to go on to the next stage of the more traditional research routes. So you're pumping out a lot of discovery potential. You need to scale up the ability to validate that potential so that you can get it to the point where it then goes into animal studies and then into humans. And of course, coming back to your point of being scared of these things, you can't shortcut the necessary stages of clinical development, which can take up to 10 years. So what's happening is these therapeutics are being developed. Some of them are very early stage. There's a 9-stage process. They're in, kind of phase 2 or phase 3. They're not in humans yet, but there are other therapeutics that are further along the line that are in humans that are moving into phase 2 and potentially phase 3, which is really very exciting. And you can see that Biogen, for example, I just read an article the other day, about a year ago, they got one of their drugs for Alzheimer's approved, which meant that they went through the whole process of rigor. It was a very gnarly process for them, because the FDA and the industry wasn't completely convinced. It wasn't a unanimous decision, but it got into market. 1 year down the line, they've taken it off the market.
Really?
So sometimes, you can see that it goes through all of that process. And again, whether it's the FDA in the case of the US, or the regulator in that country, or the company themselves, there's no slam dunk sometimes on all of these things. So the longevity next industry, which is where billions of dollars are going in, I mean, literally billions of dollars are going in every year. It's developing the future from 10 years to 15 years from now of how humans are going to be in terms of the therapeutics that they've got access to. So this is the concept of longevity escape velocity, which is to stay around long enough so that when these therapeutics come in, you're still around and you're still healthy and you're still mobile. And if you're able to freeze yourself at that particular point in time, then if you're 72 and you're a fit 72-year-old, then the concept is that you might stay like that for a much longer period of time than you would have done if these therapeutics weren't available to you. So that's when we're starting to talk about people living into their hundreds, their 120s, in the way that we're now talking to people as people moving from their 80s as an average into their 90s as an average.
I think that's one of the most fascinating intersections at the moment, like the ancient nature of biology and the intersection with AI, and how you were saying how AI is formulating and coming up with potential therapies so fast, but we just need to, thankfully we've got the research behind them and the necessary steps to bring them to market that you mentioned. But it is such an interesting time when we look at almost the untapped potential of AI to discover formulas and strategies almost that can affect biology. This ancient being that is biology,
Yeah, and don't forget what it's not just the ancient biology, but it's also the ancient psychology, right?
Yeah.
It's the potential that the things that this industry is presenting are not science fiction, that they're actually real. I've been through a number of market phases. I've seen the internet go from nothing to what it became. Obviously, we're witnessing now sustainability You know, it's a long, hard road, but we're seeing way more renewables around the world. And of course, we're now seeing what's happened with AI and how AI can be obviously so beneficial, but also so disruptive. And that's at all levels, you know, whether it's more efficient farming or deep fakes about politicians, right? You know, there are two sides to every coin. And going back to the discussion that we had right at the beginning, this concept of more and more and more old people, well, the concept is that actually birth rates are declining, and we want to be in a position where, of course, we have a sustainable planet full of healthy people. And then you tie that into what's happening with space and the concept of off-planet colonies and so on. And there's a lot of crossover between the space industry and the longevity industry, because obviously the travel times are significant, so therefore longevity does come into play. But like astronauts do age in space much quicker than they do on Earth. So space, in fact, is a very interesting research platform for a lot of longevity therapeutics. And interestingly, we ran an article last week about squirrels going into space. There's a wonderful company called Fauna Bio that use the techniques of hibernation to understand how that can be applied to longevity therapeutics. And so squirrels in space.